Greetings, this is m squared, and we are going to factor some polynomials. This is in preparation to solve quadratic equations by factoring. I am assuming that you've already factored before, so this is not like a beginning lesson on factoring trinomials or polynomials. So if you are just starting this, probably Algebra 1, this might not, some of this might not make sense. Let's remember what the first step is in factoring. No matter what you're factoring, the first step is to find the greatest common factor. There isn't always one, but you always want to look for that too first. If there is one, you want to factor it out. So just keep that in mind. And then depending on what we have, there are different steps. So we're just going to write that one down. So this first expression right here, it's a trinomial. There is not a greatest common factor. These have x's, but this one doesn't. These have coefficients or numbers, and this one doesn't. So we know there's no greatest common factor. So we skip that step. The next step is, if it's a trinomial and we have that x squared x number thing going on, is to do the opposite of FOIL, where the firsts in each of these parentheses, each of these factors, multiplies together to get x squared. And if you have an x squared, it's always x and x. Always, always, always. If that's x squared. And then the lasts in each parentheses are going to multiply to get 15. But when you combine them, the outers and the inners, they're going to add to equal 8. That's why I have this little chart that I make. I put a 15 here, it's positive 15, and an 8, it's a positive 8. And I list all the factors of positive 15. So that's 1 and 15, 3 and 5. And then I add them and put them in this column. So this is the multiplication or the factor column. This is the adding column. So here I get 16, and here I get 8. And I look for the same number that is the coefficient on that linear term, and it's 8. That means these are the two factors. So I'd say plus 3, plus 5. It doesn't matter, remember, which order you put them in. You could, on this particular one. Sometimes it does. We'll get to those. Bottom two it does. But right here it doesn't. To double check, we say x times x is x squared, 3x plus 5x is 8x, and 3 times 5 is 15. So these are the factors of this trinomial. This is the factored version. So that's what they asked you to do, is factor these. You're done when you have that factored. Over here, our first step again is our greatest common factor. There is one. That's divisible by 3, and so is this. So I factor out, the first thing I do is factor out a 3 from my expression. And that's kind of like dividing by 3, if you want to think of it. If I divide this by 3, I get an x squared. If I divide that by 3, I get a 5. And then I check to see if anything left, if what's left is factorable. And it's not. This could be a difference of two perfect squares if this was a perfect square, but it is not. So we're done. That is factored. Over here, greatest common factor, because they both have an x. So I factor out an x. And when I do that, remember, it's kind of like dividing. I get an x minus 5. So that is the factored version of that. Over here, we know that's an x squared, so we have to have an x and an x. That's a 12, and it's a negative 12. So when I make my chart, that's a negative 12, that's a negative 4. I'm looking for two things that multiply to get a negative 12 and add up to negative 4. Well, if it multiplies to get a negative, I need a positive and a negative. And since it adds to get a negative, the larger factor, the absolute value of that factor, has to be negative. So when I write down my factors, I use the smaller one as the negative one. And the larger one, did I say smaller one is the negative one? Smaller one I want to be positive, larger one I want to be negative. So those are my factors of negative 4. I want them to add up, negative 12. I want them to add up to negative 4. That's this one. So I know that my factors, my numbers will be like this, a positive 2 and a negative 6, because that's what added up to get that negative 4. So this is where I do my work. You can use the guess and check method, and sometimes that's a little easier depending on the problem, but if I have, I like to just get it organized like this. So hopefully that is helpful to you. And we're done. And you can check, x times x is x squared, then we get a 2x minus 6x, which is negative 4x, and 2 times negative 6 is negative 12. So this chart right here works really well when you don't have a coefficient of the quadratic term. See how a is 1. Here, not so much. So you have to remember that if you want to use that chart, now over here we don't just put C we put a times c, and we don't just, but we still put b right here. Now, I might not use a chart on something like this that's so simple, and let me explain to you why I know this is a simple one. Because this is 2 and that's 3, and they're both prime. And that means my factors are limited. For example, on the 12 I had 3 sets of factors, but over here for 2 I only have 1 set of factors. It has to be 2x times 1x. It can't be anything else to get that 2x squared. And for the 3, it has to be a 1 and a 3, or a 3 and a 1. So I don't know if it's like this or like this, but I know those are my only options if this trinomial is factorable. So on this particular one, if these are both prime, I just guess and check instead of make my chart. But I can show you how I'd make my chart in a minute. So I'd say, well, if the 1 was there, I'd have a 1 times 1 and a 2 times 3. And that's a 6 plus 1, minus 1. So that doesn't work. So it must be a 3 and a 1. And since I want this middle term to be positive, I want that bigger factor, that 3x, to be positive, and this 2x to be negative, because 3x minus 2x is going to get me that positive 1x. And then I check it. Does 3 times negative 1 equal negative 3? Yes. I already checked this one and got just x, and then this I already checked as well. So let me show you how to do this. If I was to use the AC, I would have gotten a negative 6 here and a positive 1 there. And since this is positive, I want my bigger factor to be positive, so I would have gone like this. And you'll see that I got a negative 2 plus 3 to equal my 1. But notice these two didn't equal negative 2 and 3. So you have to remember, when there's a coefficient there and you put AC here, what you're finding when you do this t-chart, these two factors that we normally would use to put in our parentheses at the end, they really are what you get when you do your outers and your inners. So you see the 3 and the negative 2 there, that's what they are. So you have to do a little more manipulation. So it's a little trickier. We'll try it on this one. So let me do my AC. 3 times 4 is 12. I'm getting a negative 8. Well, the only way I can multiply to get a positive and add to get a negative is if they're both negative. So I need an 8. So I do my negative 1 times negative 12. And I already have the factors listed there. Negative 2 and negative 6, negative 3 and negative 4. Now, you don't have to write all of them. If you knew it right away, hey, 2 times 6 is 8, then that's great. 2 plus negative 6, sorry. Negative 8. So we know it's this one, but remember, I need a 2 one way and a 6 the other way. So that's the tricky part. I'm going to put 2x here because I want a negative 2x and a negative 6x here. And then I take care of this one. This is prime, so I know I need a 3x and an x. And once I establish that, it's really quite easy, because if I'm multiplying something by 3x to get a negative 6x, the only thing that works is a negative 2. And once I do that, well, I need a negative 2 here as well to get my negative 2x. And so that wasn't so hard once I knew what these equaled, what those outers and inners equaled. Always double check. 3x times x is 3x squared. That's negative 6x plus negative 2x equals negative 8x. And a negative 2 times a negative 2 is positive 4. So that's kind of how you use the t-chart with an expression that has an a that's greater than 1. So good luck factoring polynomials. This is M Squared signing out.